Hi everybody. In this lesson I want to talk about logarithmic functions. In particular, just give an introduction to the language of logarithms so that you come to understand that they're not as scary as they might seem at first. Now here's the really big important fact for understanding logarithms. A logarithm is simply an exponent. And you already know about exponents. In fact, every exponential form with which you're already familiar has a corresponding logarithmic form. So we know that 2 cubed is 2 times 2 times 2, that's 8. And you're used to writing it this way, but there's another way you can write that same relationship, and that is to say that the log base 2 of 8 is equal to 3. This and this say exactly the same thing. It's just another way of writing it. And you want to learn to say it just as I said it. It's the log base 2, and the base corresponds to this base over here, of 8. So you take a logarithm of a number, kind of like you take the square root of a number. And the log base 2 of 8 is equal to 3. Now remember, a logarithm is an exponent. So the logarithm is, it equals 3, and 3 is the exponent. So since 9 squared is 81, I could rewrite that in logarithmic form as the log base 9 of 81 equals 2. 3 to the negative 2. Now remember, that means 1 over 3 squared. That's equal to a ninth. So 3 to the negative 2 is 1/9. That means that the log base, the base is 3, of 1/9 is equal to negative 2. This says the same thing that this says over here in exponential form. 2 to the negative 4th would be 1 over 2 to the 4th. That's 1/16. 2 times 2 times 2 times 2 is 16. So another way of writing that in logarithmic form would be the log base 2 of 1/16 equals negative 4. All right. Notice the way that you read a logarithm is this little subscript right here. That's the base. So 2 to the negative 4 power is 1/16. 3 to the negative 2 power is 1/9. 9 to the second power is 81. 2 to the third power is 8. So it really is just another way of writing an exponential. Now 9 to the 1/2. Do you remember what that means? This is a rational or fractional exponent, and the denominator is a root. So this is the same thing as the square root of 9. That equals 3. So in logarithmic form, that would be the log base 9 of 3 is equal to a half. In other words, you raise 9 to the 1/2 power to get 3. All right, let's do a few more like that. 8 to the 1/3, that's the cube root of 8, that's 2. So in logarithmic form, that would be the log base 8 of 2 is equal to a third. You raise 8 to the 1/3 power to get 2. 8 to the 2/3 power, well, I have to take the cube root of 8, that's 2, and square it. 2 squared is equal to 4. So since 8 to the 2/3 is 4, that means the log base 8 of 4 has to be 2/3. If x to the y is z, that means that the log base x of z has to equal y. Remember, the logarithm is always equal to the exponent. If e to the third power is q, that means the log base e of q is equal to 3. It equals the exponent. All right? Now, let's turn our thoughts sort of the opposite direction. Suppose I'm looking for the log base 4 of 16. I'd like to know what is the log base 4 of 16. And I remember that a logarithm is an exponent. That's the big important fact. And so I'm looking for the exponent. I raise 4 to get 16. Well, that's going to be 2, right? Because I raise 4 to the second power to get 16. The log base 7 of 49, that's looking for the exponent I raise 7 to get 49. That's also 2, because 7 to the second power is 49. if I say, what's the log base 5 of 1/25th, then I have to find the exponent that I would raise 5 to get 1 over 5 squared. Well, that's a negative 2, right? Because 5 to the negative 2 power is 1/25th. How about if I wanted the log base 25 of 5? What power do I raise 25 to get 5? Well, that's the 1/2 power, because 25 to the 1/2, in other words, the square root of 25 is equal to 5. The log base 2 of 16, that's 4, because 2 to the 4th power is 16. How about the log base 16 of 4? Well, how do I get from 16 down to 4? I take the square root of 16, right? So that's going to be 1/2, because 16 to the 1/2, or the square root of 16, is 4. How do I go from 16 down to 2? What power? What's the log base 16 of 2? What power do I raise 16 to get 2? Well, that's the 1/4 power, because 16 to the 1/4, the 4th root of 16, is 2. Now this one's a little more tricky. How about the log base 16 of 8? Well, I'd have to think in terms of an exponent, so I'd have to take a root of 16 down to 2, so that'd be the 4th root of 16 would get me down to 2, and then I'd have to build that 2 back up to 8 by cubing it. So this ends up being 3/4, because 16 to the 3/4 power is going to equal 8, right? If I take the 4th root of 16, that's 2. 2 cubed is equal to 8. All right? Another way you could do that, and that's this one here is definitely more difficult. So if you don't see that right away, you would not be an unusual student. But what you could do is you could, just for a moment, you could say that the log base 16 of 8 was equal to x. And then you could rewrite that in the corresponding exponential form, right? This means, another way of writing it is this base 16 to the x power is equal to 8. And you might notice that 16 and 8 are both powers of 2, so I could write 16 as 2 to the 4th power, and write 8 as 2 to the 3rd power. So 2 to the 4x power, by your rules of exponents, would have to equal 2 to the 3rd power. And it turns out the only way that that can happen is if this exponent 4x is the same as that exponent 3. So if 4x is equal to 3, that means x has to be 3/4. Okay, and that's what we got up here by just trying to think in terms of the roots and the powers. All right, let's do these last two. The log base 27 of 3, that would say, well, what power did I raise 27 to get 3? Well, that would be the cube root, right? It would be the 1/3 power. The cube root of 27 to the 1/3 power is 3. How about if I wanted the log base 27 of 9? Well, that's kind of like this one. I'd have to take the cube root of 27 to get 3, and then I'd have to square the 3 to get 9. So that ends up being 2/3. If I take 27 to the 2/3 power, that does equal 9, right? Again, the cube root of 27 is 3, and if I square the 3, that'll give me 9. All right, so it turns out most of the problems students have with logarithms really aren't so much with this language of logs as it is with just becoming more proficient with their rules of exponents. We have negative exponents, we have these fractional exponents, but it really is as you work with logarithms that you'll become more proficient with your exponents. So don't give up hope if this seems a little hard, especially these last couple examples here. All right, just a few more here. Suppose I wanted to solve each of these equations that are given in logarithmic form, and it's just as simple as just rewriting these in exponential form. If the log base 4 of x is 3, remember that means that this base 4 raised to this exponent 3 has to equal x. Well, I just solved it, right? That means x is 64. 4 cubed 64. I'm done. Here I would have the base 3 to the x power has to equal 81. Well, 81 is 3 times 3 times 3 times 3. So that would mean that x would have to equal 4. Okay, so the log base 3 of 81 is 4. How about the log base x of 8 equals 3? Well, that would mean that x to the 3rd power has to be 8. Well, what number do I cube to get 8? Well, I take the cube root of both sides, and x would be 2. Here I'd have 2 to the negative 1 power is equal to x, the base 2. The exponent, the logarithm, is equal to the exponent, negative 1. And so x has to be a half, right? 2 to the negative 1 is a half. And I'm done. See how easy these are? Here I'd get x squared is equal to p. So x would have to be, well, just solving this equation, I'd get plus or minus the square root of p. But it turns out that the base of a logarithm can't be negative. All right? So in this case, your only answer would be x equals the square root of p. And on this one, I'd get 9. The base is 9 to the 3/2 power equals x. So 9 to the 3/2 power, well, that's the square root of 9. That's 3, and 3 cubed is 27. All right, so I hope you find this introduction to the language of logarithms really helpful, and you begin to see that they're really not as maybe terrifying or scary as they might look at first, and you just have to get used to the language. All right, good luck on your logarithms.